afternoon, everybody, and welcome to your fourth science lesson in our properties and changes of materials topic, which is our Year 5 curriculum catch-up. So the learning objective today is to explain that some changes result in the formation of new materials, and that this kind of change is not usually reversible, including changes associated with burning and the action of acid on bicarbonate of soda. That's quite a lengthy learning objective, but we learned over the last few weeks that some changes are reversible, for example, our mixing or our dissolving. However, we know that some changes after this lesson create new materials and that these changes are usually not reversible. And this gives you some examples there, for example, burning or using acid on bicarbonate of soda. That's what that learning objective means today. So the key vocabulary we need to know for today's lesson is reversible, irreversible, physical, chemical, reaction, reactant, and product. Some of these words are new today, so we need to make sure we're really happy with what they are as we're going through the lesson today. So far in our topic, we've looked at separating materials using scientific methods. That was our first lesson. And we've also looked at a variety of reversible changes, including doing our own experiment to prove that some types of mixing and changes of state can be reversible. So what's next in our learning sequence? Well, if you're listening to the learning objective, you'll know that we're moving on to irreversible changes now. And if you're good at your SPAG, you know that the prefix of IR indicates that something is the opposite. So we're changing reversible states to the opposite, irreversible states. So the first thing we're going to do is we're going to watch this video. Now, if you're learning from home, the video link will be in your description, the lesson description. So you'll need to stop the video here and you'll need to watch the video from the video description. If you're watching in school on the PowerPoint, then you can click on the link. As we're watching, I want you to make notes about the changes that are happening, the change of state that you can see, and have a little think about the irreversible changes that are happening, changes that can't be changed back. Pause the video now and watch the video. So now that we've watched the video, we can look at some of these key ideas: chemical reaction, reactants, product, reaction, and physical changes. And some of these were our key vocabulary from before. Well, first off, we've got reactant and product. You'll remember from the video that the reactants anyway, each chemical reaction starts with reactants. And those are the things that react together to create the new product. So reactants are almost like your ingredients. Product is what is created after the reaction has occurred. So in the video, the ingredients were the reactants and the cake was the product. And what occurred was a chemical reaction. And after that chemical reaction, there was a large physical change. That's how that vocabulary all combines together. You need to be comfortable explaining this process. That we start with the reactants, we add energy, potentially heat, and there is a reaction, a chemical reaction, which creates a brand new product. There's a physical change to the reactants when they become the product, for example, colour changes or taste changes. This is very different to when we were dissolving the salt in the water, for example. And it's mainly different because these are irreversible changes. We cannot get the original reactants back from the product. So what changes did we see in the video? Well, what was the reactants? Can you remember? Well, to begin, we had a raw egg. And then later on, we had flour and sugar and water. What were the products? Well, with the egg reactant, we still had the same egg, but the egg had a different physical structure. It was a lot firmer. It would taste different. The consistency changed from a liquid to a solid. In the cake example, the product was the cake. And we could see there was a change of colour, a change of firmness, and there would have been a change of taste. What caused these chemical changes? Well, in both our examples, it was heat energy. The reactants, when we had heat energy added, created the new product. Most chemical changes require some sort of energy, but not all of them. Can you remember what the example from the video was that didn't require a chemical change? It was the bicarbonate of soda. The mixture of those two reactants, they naturally reacted together to create a new product. So the eggshell is cracked and the raw egg pours into the pan. As the liquid egg white and the yolk are heated, they start to change. The clear liquid egg white firms up and becomes opaque white. It changes into a solid. The orange liquid egg yolk also solidifies and turns lighter in colour. I've highlighted there some of the key vocabulary about what's happening in the video. Down the side, I've included some different labels, energy types, change of colour, change of state. Can you match those titles with the words I put in yellow? Pause the video there and see if you can do that. Let's have a little look at this together. So it says, as the liquid egg white and yolk are heated. Well, liquid is highlighted in yellow. Well, liquid is part of the change of state because it changes state later on. So liquid is the current state it's in. And though the egg white and the yolk are heated, and heated is the energy type, so we could label that energy type, and they start to change. The clear liquid egg white firms up. That is a change of state again. That's becoming a solid and becomes opaque white. Well, there's a change of colour. It changes into a solid. That's another change of state. The orange liquid egg yolk also solidifies, change of state, and turns lighter in colour, change of colour. So we can see there that in our chemical reaction there was lots of changes of colour and lots of changes of state. So what's the difference between a physical change and a chemical change? Well, a physical change is things like melting, freezing, evaporating, condensing and dissolving. They're all examples of reversible physical changes. These are physical changes because no new materials are created. They are reversible changes because they can be changed back or reversed. So these are kind of like the changes we were looking at the last few weeks. For example, dissolving the salt into the water. There's no new product made and we can get the original products back. So to think about, are all physical changes reversible? Then we've got chemical changes, and that's what we'll be looking at today. The egg cooking is an example of a chemical change. The heat causes an irreversible chemical change to occur, and a new product is created. The cooked egg cannot be cooled and turned back into a raw egg. It is a chemical change because a new product has been made, and irreversible because it cannot be changed back. Something else to think about. Are all chemical changes irreversible? So I'm going to show you some pictures, and this is your task for today. I want to separate your page into physical and chemical changes. I also want you to separate your page into reversible and irreversible. So actually you'll have quadrants, you'll have 4 sections on your page. One will be physical reversible, one will be physical irreversible. One will be chemical reversible and one will be chemical irreversible. If one of the pictures I show you is a chemical reaction, I want you to identify the reactants and the products. Once you've split your page into 4 and labelled them the correct sections, carry on with the video and we'll see what pictures we've been given. So here are your 8 pictures. Chocolate melting, bread toasting, candle burning, wax melting, sugar dissolving, wood burning, biscuits baking and water boiling. What I want you to do is to place these changes into your quadrants. So let's do 2 together. Chocolate melting. Is that a physical change or is it a chemical change? Is this a change where the change is simply a change of state, where nothing new is created? Or is this a chemical change when a brand new product is created from reactants? Well, from our experiment last week, we know that chocolate melting is a physical change. Nothing new is created, it's just a change of state. So chocolate melting is a physical change. Now we need to decide, is it reversible or is it irreversible? And again, from our experiment last week, we know that chocolate melting is reversible. We can get back the solid chocolate form. So this is a physical reversible change. So we would write chocolate melting in that section. So the next one is bread toasting. This is a tricky one. Is bread toasting a physical change or is it a chemical change? Are we creating something new through the change? So bread toasting is actually a chemical change. The bread is the reactant and the heat energy that we use creates a brand new product. It creates toast. So this is a physical, no it's not, it's a chemical change. Can you get bread back after you've been made it into toast? You can't. It's staying as toast, and no matter how much you cool it, you're not going to get the original bread state back. So this is an irreversible chemical change. Can you try the next 6 by yourself? Pause the video there and have a little go. Okay, so here is my example. These are the reversible physical changes: chocolate melting, wax melting, sugar dissolving, and butter melting. You can notice there's a bit of a pattern there in terms of melting and dissolving. We know that those are physical changes from our experiments last week. Down in the bottom right, we've got our irreversible chemical changes, which is bread toasting. The reactant is bread and the product is toast. The candle burning, the reactant is the wax and the product is CO2, carbon dioxide. That's a really tricky one. The actual wax melting is a physical change because we can get the wax back. The actual candle burning, the wick, that is not a physical change. It's a chemical change. It's a brand new product being made. And the wood burning as well. The reactant is wood and the product is carbon dioxide and ash. So that's also a chemical change. And with all of those, you can't get the original product back. So they were all reversible physical changes or irreversible chemical changes. Just to show you that you can have irreversible physical changes, I'll give you some examples, like grinding wood or cutting grass. We're not creating a new product, we've just got ground up wood and cut up grass, but actually we can't get the original product back. So that's an irreversible physical change. There are very few, if not any, reversible chemical changes. There are some examples online, but they are very scientific and more for university students, so we're not really going to look at them today. For your notes on today's session, I would like you to have the following on your paper. I would like you to have a definition of each of the key pieces of vocabulary. If you don't remember what they are, go back to the beginning of the video and have a little look. I would like you to define what all of those words mean now that you've had the lesson. I would also like you to have a description of how the egg changed, the chemical reaction of the egg. There is an example on the video that we've looked at, so you can use that for support if you like. And then finally, I would like your quadrants, a copy of your quadrants. There are 3 things that you will need to submit for this task.